Now that we have learned about hypothesis testing, let's see how we can use R to test a hypothesis. I've created a script. Let's follow through. Recall that the recently rescaled GRE has a mean of 150 and a standard deviation of 8.75. So the first thing I'm going to do is create variables for these values. I'm going to set a variable called mean to be 150 and a variable called standard deviation to be 8.75. GRE preparation services claim to be able to increase GRE scores for those who go through their program. The mean from a random sample of 64 participants in one such service was calculated as 153. So first, let's use what we know about the sampling distribution of the mean to find the mean and standard deviation of this sampling distribution. And we're going to use a null hypothesis that the population mean is 150. Well, the mean of the means is equal to the mean of GRE scores. So let's create the mean of the means. The standard deviation of means is the standard deviation of scores divided by the square root of the sample size. Let me go ahead and create that. Now let's calculate the probability of obtaining 153 or larger and draw a picture. You may recall that we can use functions for doing this as long as we include the normal dist areas.r script. We have to make sure this is in our project folder. If I look in my files for my project, I see indeed I have normal dist areas.r there. So once I know it's there, then I can use the source function to tell this script it's going to use that script. So now we can use the function norm area above. I want to use 153 as the value I'm interested in, and I want to use the sampling distribution. So I need to put in the mean and standard deviation of the sampling distribution. The mean is in the variable mean of means, and the standard deviation is in the variable standard deviation means. Let's run this. Here's my picture. If I'm writing a report and want to include this picture, I can easily export it. But suppose that we want to test the hypothesis without drawing the picture. Well, for that we can just use p-norm to calculate the percentile rank of our value of 153. Let's do that. That comes out to be 0.99, about 7, 0.997. So we know that 99.7% of the area of this distribution is below our score of 153. To calculate the p-value, we need to get the amount of the distribution that is above 153. We can do this if we subtract from 1. So that's what I'm going to do. 1 minus p-norm of 153 using the mean of means and standard deviation of means. There's my p-value, 0.003. If I have set my type 1 error rate to be no greater than 5% or 0.05, I see that my p-value is less than 0.05, so I can reject the null hypothesis of 150 and conclude that the test preparation did indeed raise the mean of everyone in test preparation, that is, the population parameter. The cool thing about this is that we are making statements about a population parameter without using the entire population, which is inaccessible to us. Instead, We are just observing a sample of 64 students, and based upon the mean of these students, we can make a statement about the population parameter, namely, that the mean for the population for those in test preparation is greater than 150, which is the mean of the GRE scores for all students.